So with GPS virtualization, what we do is we don't actually go ahead and virtualize a real GPS. Similar to the case of NAND devices, these are quite complex things to actually virtualize, and there's no need to actually do this if you can virtualize higher up in the stack. And in Android, things are actually very convenient. Android's designed to allow not just pluggable sort of kernel drivers to support the GPS, but also pluggable libraries for the GPS and navigation services. And so you're actually able to intercept sort of guest interactions with the GPS much higher up in the stack and actually elide the guest kernel driver and device models. And so what we actually do is we provide a replacement library there for Android's location services. And so when the guest tries to sort of look up its location, it accesses the Java location libraries, which then speak down via the Java native interface to this library there, which then calls across to the host and makes use of a similar set of libraries there, which then actually make use of the physical GPS. So this enables a relatively simple implementation and one which works, at least in the Android context, for all the applications that we're concerned with. In general, when you're virtualizing at the library level, well, you have the concern of, well, what if my application isn't linked with the library that I'm actually providing replacement for? On Android, it's not such a concern, as anyone who's using the location services will be accessing via the Java virtual machine, which will be linked with the libraries that we're actually para-virtualizing. So that's GPS virtualization. And finally, there's sort of telephony virtualization. And here, the sort of I/O, the front end is usually something very simple, like just the dialer itself, almost at the application level. And this usually makes use of host services to do almost all of the telephony. And so most of the mechanics of placing and receiving the actual call and sending the audio in and out will usually take place on the host, with the exception of perhaps, let's say, voice over IP-based solutions where you may be running things within the guest and doing things directly from there. Now, the actual back ends of these, well, exactly how you sort of realize telephony virtualization and have more than one phone number on a mobile device really depends upon a couple of things. It depends upon the carrier you're working with, the geography you're in, the set of phone hardware, the support the enterprise has, and so on. So, solutions exist, let's say, using actually at the radio layer, using the GSM standard. Some phones support multiple SIMs. This is maybe, say, somewhat common in China, but not so common in the United States. There is, in the GSM standard, alternate line service for supporting multiple lines. This works as long as your carrier or the network supports it, but that's sort of not universal. And then there's sort of other approaches like network-based approaches like call forwarding, similar to, let's say, Google Voice, and many of you are familiar with that. And there's sort of a mobile-specific variants of that, like Line 2. And finally, the sort of VoIP techniques, which are becoming sort of increasingly practical as the sort of the bandwidth and latency on mobile devices improves. And in particular, let's say 4G LTE, these are very practical. And in fact, one day we may see all mobile voice traffic be based on VoIP. And these may take the form of something like Skype, which you're familiar with probably, or some sort of enterprise variant, which integrates tightly with their particular sort of VoIP network and other sort of networks. This thing called unified communications.